Hey, how's it going? Let's talk about some of the homework problems in section 1.2. I know this can be confusing right off the bat, and getting used to the math. In addition, getting used to this new software and how you enter your answers can be a problem. So I have several of these problems selected to go over. You'll notice that some of them have the answers down here at the bottom if you want to go ahead and look at the correct answer, but I'm going to show you how to get the correct answer on these problems. So we're supposed to consider the graph to the right over here and answer the following questions. And the first question is, the shaded set of numbers shown on the x-axis can be expressed in interval notation. So I want you to notice the shaded, what they mean is this that I've just highlighted in pink, and they want that written in interval notation. Now mine's really small here, and these links don't work, so I'm not actually inside the homework. This is just a PowerPoint presentation. But you always do intervals from left to right. And what an interval means is it's all the numbers between one number and another number. So notice this interval that's highlighted in pink, the furthermost point on the left is 0. Okay, and notice there's a bracket there. Notice that point is included. Whenever you want to include an endpoint, you use a L bracket is what we call that. Notice everything in between 0 all the way to 4 is shaded in pink on top of their dark black that they use. So it goes to 4. But notice over here at 4, there's an open circle. And that open circle over there means you do not include that endpoint. So that's the answer that's listed right here, the interval 0 to 4 with 0 included and 4 not included. Now, if you ever miss a homework problem, you can always select a similar question and do another one like it. So there's no reason in the end, after you feel comfortable with all the material, that you don't have 100% on every homework. So if you miss a problem 3 times and then they give you the answer, like this example right here, all is not done. Click similar question so you can try another one, which is often exactly like the one you just did, which is some different numbers, and you can keep going with this. So we can improve all grades to 100. Now the set represents the function's domain. Notice these are x values, and x values are always the input, which is domain. Anything along the horizontal axis is domain. Along the vertical axis is range. Okay? Okay, so the next problem, they gave us a set of ordered pairs, and this is called a relation. Whenever you have a set of ordered pairs, often what they'll ask you is, does the relation define a function? And that's exactly what they're asking here. Does determine whether the relation is a function, give the domain and range for the relation. Okay? Now, first of all, the domain, notice again the answer is right there, but let's take a look at it. Now the domain is the input, which is the x values. It's going to be the first numbers in line. Now what we don't want to do is say 7, 7, 7, because that's just the same number 3 times. That's really not the way you want to say it. If you have a number that's repeating, you just write it 1 time. So the domain is 7. If you were to do this on paper, you would have to do the curly braces and the 7, but I've noticed the homework likes to put the curly braces there for you. And then the range, I'm just going to denote with an R for range, is going to be the output, which are your Y values. Do you have to put those in order? Well, to be correct for a set, it doesn't have to be in order, but this homework likes you to put your numbers in ascending order. So instead of doing 11, 10, 9, I'm going to do 9, 10, 11. Notice those are the correct answers here. Does this relation define a function? Listen, the definition for a function is for each x, there's only one y value. Now that's slightly oversimplifying the definition of a function. Really it says for each element in the domain there is exactly one element in the range. But for the standard xy axis, the domain is your x and the range is your y. So this is completely safe to say down here. Now when we look, and I'm going to erase all my highlighted stuff here, when we look at this relation we've got above, for each x, is there only one y? And the problem is no. For x equals 7, there's 3 different y values. There's a 9, there's a 10, and there's an 11. And we can't have that in a function. It's still a relation, but it is not a function. So the answer to this is no, this relation is not a function. Another example or question they want to ask is, if they give us an equation, is this a function? Now the steps for this, step 1, solve for y. And this is really where all the work comes in. Sometimes you'll find me only doing this in one step, but solve for y. So if I were to solve this equation for y, you look at that and you go, there's more than one y. What do I do? Well, first of all your y's need to be on the same side of the equation to solve for it. Well, we're good there. So xy plus 7y, those are on the same side of the equation, both on the left, and there's no y's on the right. So, hey, we're good. The next thing is I can't solve for this y and not mess with this one, or this one and not mess with this one. So what am I trying to say? Well, we got to factor that y out. So if we factor this common y, it's called a greatest common factor, pull that y out, and that's going to leave me with x plus 7 in the parentheses. Now if you feel uncomfortable with that, imagine backwards. If I were to distribute this y back inside, y times x is xy, y times 7 is 7y. So yes, if I pull a y out, I'm really dividing each of those by y. I pull it out front, and that gives me that. Now, why did I do that? So I could get that y by itself, because my next step is to divide both sides by x plus 7. Okay? Well, I've done it. I've solved for y. Y is equal to 8 over x plus 7. Now, that's not my answer. My answer is yes or no, right? Does this define a function? Well, step 2 of this process of determining if an equation defines a function is to ask yourself, is that one answer for each x that I could possibly plug in, or more than one? Well, you know what? There's no plus or minus right here. The only time you put a plus or minus when you're solving is when you take a square root, a fourth root, a sixth root. So for each x we plug in, we only spit out one y answer. So for each x, is there only one y? And the answer is yes in this case. And again, the simple way to look at that is there's no plus or minus when you solve for y, because you didn't have to take a square root, a fourth root, a sixth root, that sort of thing. So the answer to this is yes. So we have a nice review question here, but sometimes the review questions are harder than the actual questions. So they want us to solve and check this linear equation. So we're supposed to solve for x, right? That's the only variable in this problem. So to do that, you know what I'm going to do? I've got to distribute the 4 inside on the left and the 3 inside on the right. Because the problem is I have x's on both sides of this equation. Remember, just like the last question, we need all of our variables on the same side of the equation to be able to solve. So when I distribute that 4 inside, that's going to give me 4x minus 8. That plus 19 is still on the left. And now on the right, I'm going to do the same thing to get 3x plus 15. Okay? Now, here's what I suggest. Why don't you combine like terms? So on the left, you have 4x plus 11. And on the right, you have 3x plus 15. Okay? Now, each side, if you look at them independently, the left side, 4x plus 11, is completely simplified. I cannot add those together because they're not like terms. 3x plus 15 is completely simplified. I can't combine those together because they're not like terms. What can I do? Well, I need all those x's on the same side of the equation. I can't have some over here and some over here. So to fix that dilemma, I'm going to subtract 3x from both sides. So this 3x minus 3x is gone. And now, on 4x minus 3x, I have 1x, which we just write that as x. The 11 is still there. 15 on the right. Right? We're almost there. So what do I need to do next? I need to subtract 11 from both sides of this equation. All right, the 11's cancel, and I still have x remaining on the left side of the equation. 15 minus 11 is 4 remaining on the right. This appears to be my answer. It did want me to check. I'm going to do that a little bit faster and a little bit smaller and in a different color. So I have 4 parentheses 4 minus 2 plus 19. Is that equal to 3 parentheses 4 plus 5? Okay. Remember, I'm just checking. Now, whenever you check a solution, go back to the original equation. Don't go to this multiplied out one or any of this adjustment stuff that we've done to solve for x. Go back to the original. Order of operations says I need to do parentheses first. So that's 4 times 2 plus 19. Over here, that'd be 3 times 9. Now, all we're trying to do is determine if you get the same thing on the left and the right. Matter of fact, it's probably not smart of me to work part of this and part of this. Go ahead and simplify one side down completely and then work on the other side. So 4 times 2 is 8 plus 19. 8 plus 19 is 27 on the left. Do I get 27 on the right? I do, because 3 times 9 is 27. If you get the same exact number on the right and the left, then it checks out. So that way I know my answer of 4 is correct. Now this problem is all about interval notation, and a lot of students have trouble with interval notation, so I get it. The A is the one you want to master first, and A is just substituting in a number. So when you see this notation, that's read f of -5. Now what does it really mean? It means to plug in -5 everywhere there's an x in your function. So I highly encourage you to write your function down. Notice at the top of the screen with parentheses everywhere there is an x or your variable. So notice I did that. I went parentheses squared minus 3 times parentheses minus 4. Now what am I plugging into the parentheses? The number that's inside your function. So -5 goes there, -5 goes there. Okay? Now, -5 squared, a lot of people miss this because they type it in their calculator just like I said it, -5 squared, but the parentheses are required because your calculator doesn't know you want to square the negative and the 5 without putting the parentheses. So -5 squared is 25. -3 times -5 is plus 15 minus 4. Left to right, 25 plus 15 is 40, minus 4 is 36. And notice that matches the answer above. And usually students feel pretty comfortable plugging in numbers, but what about when they change it to something like x plus 6? Now, here's what I suggest. Just like I did on the last problem, what I want you to do is write the function down with parentheses everywhere there's an x. Now, since what I'm plugging in is a little bit bigger than just a number, it's x plus 6, maybe make those parentheses a little wider, so x plus 6 goes in here, x plus 6 goes in here. What you don't do is just add 6 to the function. I see that all the time. That's not what this says. This says remove the x and replace it with x plus 6, which means this problem is kind of a lot of work because when I expand x plus 6 squared, that's x plus 6 times x plus 6 minus 3 times x plus 6 minus 4. Notice I just recopied the remainder of it. Now, I'm expanding this. So x times x is x squared. X times 6 is 6x. 6 times x is another 6x. 6 times 6 is plus 36. Okay, remember FOIL, first, outer, inner, last. That's what's happening right there. -3 times x is -3x. -3 times 6 is -18. And then you subtract 4. So now I'm going to add like terms. There's not another x squared, so it just comes down. But right here, I've got 6x plus 6x and then minus 3x. So that's going to give me 9x. And then 36 subtract 18 is 18. Subtract 4 is going to be 14. Okay, so, and then none of this can be combined together. That is my final answer there, x squared plus 9x plus 14. And notice that's what is right there for that answer. Now, C, I'm going to do the best I can to squeeze it really tightly right here at the top. I apologize for the disorganization. I just don't want to create a new page. So here we go. F of negative x. Now remember the trick is plug in negative x everywhere there's an x. So if you're struggling with this, listen. Write the original function down with parentheses everywhere there's an x. So notice I did that. Now what am I plugging in? Well, I'm plugging in negative x. So everywhere there's a parentheses, I'm plugging in negative x. Then you're just charged with simplifying that, okay? Well, negative x squared really means negative x times negative x, which is positive x squared. Negative 3 times negative x is plus 3x, and then minus 4 just comes down. Now this is completely simplified. Why? Because there's no like terms that I can combine together. Do you need to factor it or anything like that? No. When you are simplifying functions, you're not trying to, you don't have any alternate plan but just to simplify this. So there's no need to factor or set it equal to 0 or any of those crazy things that I see students do. So that's not required here. Just simplify completely. Now here's another evaluate the function, and because this is such a struggle for students, I went ahead and did another one. So again, our function, I'm going to highlight in green here so it's easy to find. And then we're going to do problem A. Now remember the trick is write the function down with parentheses everywhere there's a variable. So it's 5 parentheses squared minus 1 divided by parentheses squared. Now, I'm evaluating f of 2. So that means I plug a 2 in to all the parentheses. Now this is numerical, so I'm just going to simplify as much as I can. Now, we know that when we do order of operations, we do exponents first. So 2 squared is 4. So that gives me 5 times 4 minus 1 divided by 2 squared is 4. Now, please don't cancel these 4s. You can't, because you've got to do order of operations. 5 times 4 is 20. 20 minus 1 is 19 fourths. Unless they say, write your answer as a decimal, then the 19 fourths is the appropriate answer. And notice it says type an integer or a fraction. So that's really what we're after there. All right, on B, f of negative 2. Again, same story. Original function, that's 5. There's an x squared next, so I put parentheses squared minus 1 divided by parentheses squared. Now when I substitute in negative 2, let's just go back and do it right here. Negative 2 and negative 2. Okay. All right, so that gives me 5. Negative 2 squared is 4, right? Because negative 2 times negative 2 is 4. Minus 1 over negative 2 squared is 4, which is once again going to give me 19 fourths. Notice that's the same answer we got the first time. Why? Because the x is squared both times. So you'll get the same thing when you plug in a positive or a negative. Let's do C. So f of negative x, again, the habit is 5 parentheses squared minus 1 over parentheses squared. It's one of the best habits I can encourage y'all to have is whenever you substitute something, write the original function down, remove the variables, replace it with parentheses, and then plug in everything that it says to plug in. So I'm going to plug in negative x here, negative x here. And then our goal is just to simplify that as much as we can. Now, the next thing I'm going to focus on is simplifying this negative x squared here and this negative x squared here. Okay, now what is negative x squared? Well, it's negative x times negative x. Now we know a negative times a negative is a positive, right? And we know x times x is x squared. So that's going to give me 5 x squared, parentheses aren't needed anymore because I handled the reason they were there, minus 1 over x squared. And there's nothing else we can do to simplify that. Why not? Because I can't cancel an x squared and an x squared. You can't cancel things that are not factors. This is a term and this is a term, and you can't cancel terms or parts of terms. You can only cancel factors. So for instance, if this minus 1 was not here, then I could cancel the x squareds. But because I'm adding or subtracting, that means we have separate terms and I cannot cancel further there. Okay, another kind of problem here. Now, I like these problems a lot. And the reason I like these a lot is they get you prepared for what's coming up in a later section, but still in Module 1. So they want us to graph f of x equals 3x. And then they want us to graph a separate function, g of x is equal to 3x minus 3. Now again, keep in mind, I'm not inside the homework, so I'm not actually manipulating these graphing tools. So I'm going to have to do some stuff by hand and talk you through it. And if y'all are struggling using this graphing tool, I'll make a separate video of how to use the graphing tool if you're having trouble with it. Okay, so first of all, I went ahead and clicked to enlarge the graph. So that is done, and that's what's showing up over here on the right. Okay, now I'm graphing the first function, f of x is equal to 3x. Now here's what we know. Whenever an equation is in function form, and this is, because they named it f of x, and x is raised to the first power, you have a straight line. So the first thing I would come over here and do is hit this guy right here to graph a straight line. That's called the straight line tool. Okay. Now to graph a straight line tool, I'm going to get rid of my arrow. Notice that, I know this is tiny, but notice that on the straight line tool there are 2 dots. That means you need 2 points to graph a straight line. So once you click the straight line tool and you come over here to plot your 2 points, it doesn't matter what 2 points you plot as long as they're on that line. So if I were to do a tiny little t-table, I could plug in, say, 0 and 1. Well, 3 times 0 is 0. 3 times 1 is 3. So there's my 2 points I could plot. I could plot 0, 0, and then 1, 3. And I even have on my reading glasses and still struggling to see this little bitty thing. Now, because I clicked that straight line tool, what's going to happen that I have to draw myself is that's going to connect the dots right there, and there it is. So my straight line is going to just pop up. Okay? All right. That's what's supposed to happen anyway. Now, they also want us to graph this other guy. G of x is 3x minus 3. Okay, now once again, I know I have a straight line because I have an x to the first power. Okay, so I'm going to click my straight line tool again to graph my second straight line, but I got to plug in 2 points. So how about let's just plug in 0 and 1 again. Does it have to be the same 2 points as the other? Not at all, okay? Just need 2 points to graph. I just picked 0 and 1 because I like them. They're easy. So 3 times 0 minus 3 is 0 minus 3, which is negative 3. And then 3 times 1 minus 3 is 3 times 1 is 3 minus 3 is 0. So I'm going to plot those 2 points. Again, I've already clicked my tool again. So 0, negative 3 is right here. And then 1, 0 is right here. Now that is so incredibly close to the first graph. I know it looks awful. Yours is going to look better because you're using the tool instead of drawing this yourself. Now, the next thing they want us to do is to describe what happened, okay? So what happened between the purple graph to the green graph? Well, it turns out it moved down 3 units. Now, we're going to learn why that's the case in a later section. Section 1.6 is called Transformations of Functions, but they're kind of giving you a heads up. And I love it. So you get practice graphing and you get practice analyzing what happened between one graph and another graph. Okay, got a couple more problems to take a look at. So use the graph to determine the following. This is the teeniest, tiniest graph. I should have blew it up before I put it in this PowerPoint presentation. But we're going to do the best we can to see this, or I'm going to do the best I can. You can probably see it better than I can. And I'm using this little bitty tablet. But use the graph to determine the following. Okay, they want to know the domain of this function. Make sure my pen's working right. There we go. I'm going to make a list. The range of this function, the x-intercepts for this function, the y-intercepts for this function, f of -5, and the bottom of the screen, f of 0. All right, now, domain. What do you need to know? Left to right. Those are things you should think about when you think of domain. Another thing you should think about when domain is our x values. Now, because this left to right, how far to the right does this thing go? Like this? It goes down forever, right? But that's not how far to the right it goes. It goes to the right forever. How far to the left does it go? Well, it continues in this behavior this way, right? So how far to the left does it go? Forever. This thing extends in both directions forever. There are no holes or breaks in the graph. It covers the whole x-axis. So when you're thinking domain, again, which is left to right, you're thinking how far to the left does it go? How far to the right does it go? Does it cover everything in between? The answer in this case is yes. So the domain is -infinity to infinity. Everything is covered. If I highlight that, that's just the whole x-axis because it goes this way forever, that way forever, and all the blue stuff in between. Okay? Hey, and that's not an easy concept to get. All right, range. Range is low to high. All right, so let me write some of those words down for you. So low to high. That's one way to think about it. Another way to think about it is y values. Okay, so what y values does this graph cover? Well, notice it goes down to the left forever and it goes down to the right forever. So we're covered from way down here. Now, does it go up to infinity? It stops. How high does it go? About there. Now, this is where my eyesight is going to cause us a little bit of problem, but I do believe that looks like about -2. It doesn't go any higher than -2. So what am I truly looking at? Let me make a red dot for you. I'm looking at this point right here, the corner on that absolute value graph. And again, my dot erased because it didn't like how tiny it was. That's at -2. Okay, so when I write that, I don't write -2 to -infinity. I go lowest to highest. So the lowest thing I've got highlighted, which is down here and, way down here, is going to be -infinity. And how high does it go? To -2. Question is, do I use parentheses or do I use brackets? Well, because that red dot that I made a big deal of is on the graph, I have to use a bracket. Then you might be asking, well, why in the world did you use parentheses around infinities? Because infinities always have parentheses around them because you never actually get there is the theory. Okay, now I'm going to go erase some stuff on here so we can talk about the x and y intercepts. What about the x and y intercepts? Well, x-intercepts is where the graph crosses the x-axis. And you know this blue thing does not cross that x-axis ever. So this is none. I think in the homework they want you to use that symbol. Another thing you could say is it does not exist, but I think this is the symbol they want you to use in homework if my memory serves me correctly. Now the y-intercept, by definition, is where the graph crosses the y-axis. And so you look at the entire y-axis, the graph only crosses in one place. It's right there, and it looks to me like -5. Again, don't shoot me if I get it wrong, because my glasses are not helping me here. 1, 2, 3, 4. I do believe that's -5. How do you write that answer in? Just like this, -5. How do I like the answer? I like it as a point, 0, -5, but I am restricted to how the homework wants it, which is how tests want it also. So that answer is -5. Okay? Now, the next question, f of -5. They want us to look at the graph and evaluate f of -5. What does that mean? Well, what that really means is when x is equal to -5, what's y equal to? Because when you find f of something, you're actually finding the y value. So the x is the input, The answer is the output. So I go to x is equal to -5. And again, I'm a dum-dum for not zooming this in or making it bigger. So 1, 2. It's even labeled, but it's hard for me to see where the -5 is. 1, 2, 3, 4. I think that's the -5. And it's like right here somewhere. Y'all, I'm having trouble seeing that. So I want to say it's like -3, maybe -4. I just can't see it. So -3 or -4. I'm just trying to label the y value for that point right there. Okay. Same thing with 0. I think I can see the 0 better. So when x is equal to 0, what's the y equal to? Okay. So let me erase. I got all that I got going over here. So when x is 0, now where's x equal to 0, y'all? So x is equal to 0 right here. I go meet the graph, and that's right there. Now notice we've already looked at this before, and I thought that that was at -5, which was the same thing as the y-intercept. Okay, so you're just really labeling points. Keep in mind that is your x value, and then the answer is your y value. You're just going to that x value, you go meet the graph, and you give me the y value. Last problem to review just to help you out with this homework, and if you find more, I'm glad to do them. This was a crazy problem near the end. I'm going to write it a little bigger. It says f of -x minus f of x. All right, so let's think about this in two different ways. So first of all, what is f of -x? Okay, and then we're going to separately subtract f of x. Now, you know what f of -x means. We've already done some problems like that. It means plug in -x everywhere there's an x in your function. So I'm going to write the function down, but remember, I'm going to take out the parentheses. I'm going to take out the variable and put in parentheses. So this is just my function. Something to the third plus something minus 3. Right? Now what am I going to put in for the something? -x. So -x goes here and here. Now that's just this first rectangle. So that is just the first one. And then minus, and I'm going to do a brand new box for f of x. Now what's f of x? Well, they gave us f of x. That's it exactly, right? I don't put the f of x part, but I do put the other part, which is x to the third plus x minus 3. Now here's the deal. We don't use boxes in our problem, but this minus has to run through this whole thing. I'm subtracting that whole thing, so you know what? I need parentheses. Anytime you subtract, you're going to need parentheses after that, because your signs will be incorrect. We're subtracting that entire function. Now on the left, we just need to simplify. When I take negative and I raise it to the third power, it remains negative. So -x times -x times -x is -x to the third, but without parentheses. Plus a -x is simpler to write as -x, minus 3, minus, and then let's keep those parentheses, x to the third plus x minus 3. And if you were thinking, let's go ahead and get rid of the parentheses there, sure. -x to the third minus x minus 3. Now this negative runs inside. So this negative, x to the third, this negative makes this plus x a minus x, and this negative makes this minus 3 a plus 3. And then finally we add like terms. So I take -x to the third and I add it to -x to the third, and that gives me -2x to the third, because they're both negative. I take this -x, okay, and I add it to this -x, and that's -2x. Again, both negative. I take this -3 and I add it to this +3. Oh, those cancel out. So my final result is -2x to the third minus 2x. Notice I actually left the answer on this one, but we just worked out how to get there. So please keep in mind on homework, if you're missing them, and you miss it too many times, and it marks it just red wrong, then click similar question, and you get to do this all over again. And so mastery, it's all about mastery and getting this done, and it's all about reaching out to me when you have problems. So I'm so glad you asked, and I hope this helps you out and helps out many people. Have a great day.